he said no. My dog always growled at him. मेरी ही गलती थी जो मैंने उनकी बात नहीं सुनी. I mean, the signs were right there. हमारा Spotify blend score was 23%. 23. But it's cool. He's history now. Because I have a new date. And it's a 95% match.
Need a vibe check? Just create a blend with them. Click on the Create tab and get started.
It's that time of year again. Spotify Wrapped season is here. Wrapped is a celebration of the music and podcasts that made your 2025. And this year, it's answering all the important questions like what genres define your year? Which artist took your number one spot? And which club do you belong to based on your listening? Open your 2025 Wrapped for more stories and even more surprises. Happy Wrapped!
2, 2, 3, 5, 7. Seven, five, zero, please चल जा प्लीज चल जा कैसे कर क्या रहा करंट और इसके राइट में जो है मेरे से क्रिएटर जिसका आ रहा है निशान में से मेरा दूसरा चलिए अगर मेरे लेफ्ट का राइट इज ग्रेटर देन इक्वल टू मेरा ओवरलैप करना तो वो रिमूव कर उसका इंटरेक्शन ऑफ एल है इक्वल टू इधर मैं राइट केस करूँगा सबको रिमूव कर दूँगा उनका कॉन्ट्रैक्ट और आ रहा ही मैच मैच करते रहूँगा एनिमी इंसर्ट कर दूँगा डाल दूँगा हाँ सो ये मेक सेंस शुड वर्क आई कैट एक्सरसाइज क्या है ये वो है क्या अपना डीपी हाँ चल रहा थैंक यू वेरी स्लो दो फकिंग हेल स्पीड कहाँ है लक्ष्य स्पीड कहाँ है क्या है 500 400 कैट एग्जीक्यूट कर दो क्या साइज ओके नॉट filled in somewhere all metal set to continue. Overlaps elemental. Why permutation? Usually one पे. Ah, see. Defend होता है जब 5 3 4 1 2.
my own startup. You want it, we've got it. Great products, zero investment, leading organization, and unlimited opportunities. Now think big. Become an LIC agent.
Visit our website or contact your nearest LIC branch.
यार ये अडल्टिंग ना, रोज वही अलार्म, वही ट्रैफिक, वही 8 लॉन्ग क्विक कॉल्स। अब तो फ्राइडे भी मंडे जैसा लगने लगा है। बट जब से आई फाउंड स्पॉटिफाई डे लिस्ट, माय वाइब स्टेज फ्रेश एवरी सिंगल डे। लाइक टुडे इट्स गोइंग टू बी 90s teen rock and Monday morning. Okay, now that's something.
Have you tried Daylist? It's your day in a playlist. Search yours now.
Can't
First
get enough
impression.
of your song of the moment? Download and indulge in the tracks you loved over and over again with Spotify Premium. Tune in to discover an ad-free music listening experience where you can play your favorites in any order. Tap the banner.
कॉल कर लेना आशी मम्मी को. हाँ. एक वो ट्राई करो, उन्होंने बोला था कॉल करने को. हाँ वो भी बना देना. I see. सेवन रिमूव करा फिर मैं एक ही जगह रहता हूँ बारिश कर रही है. और एवरी 10 मिनट डिसाइड करना है लेफ्ट या राइट जाना है ना. फिर मैं लेफ्ट यहाँ पर लेफ्ट जाऊँगा, आगे जगह है, या राइट जाऊँगा, आगे जगह है. दोनों का मैच ले लूँगा आंसर. ये मेरे को बनाइए. राइट में देखो मैच से वाला होते वक्त मिल जाएगा. अपनी बाउंड्रीज चाहिए, अपनी बाउंड्रीज चाहिए, करंट इंडेक्स चाहिए और रेंज चाहिए. नो फाइल देख सकता हूँ लाइव. एक बार बाउंड्री अपना जो होगा डीपी का डीपी है तो फिर जो स्पार्स टेबल चाहिए, ये इंडेक्स और कलर और देखिए स्पार्स टेबल जैसे तरीका है. हाँ जोड़ के 42 आएगा. अरे 100 पे चल जा चल जा चल जा चल जा. हाँ runtime error. Runtime error. 33 runtime error. हाँ runtime error. Oh, query की वजह से. और zero नहीं होगा, L होगा. Fuck my life. Fucking hell. Shit. Silly mistakes. Silly mistakes. Auto check after log W नहीं. हाँ L हाँ P5 हाँ. इसी लगा दे मुझे. लेफ्ट हैंड से राइट हैंड से अगर मैं राइट में पकड़ सकता हूँ तो ट्रांजिशन डेस्टिनेशन. वो बच गया. अबे यार. फक भाई. सबका एक फालतू में टाइम लगा. ये तो मैथ प्रॉब्लम है ये मेरे. पूरा नहीं है मेरे. shall I?
It's that time of year again. Spotify Wrapped season is here. Wrapped is a celebration of the music and podcast that made your 2025. And this year, it's answering all the important questions like what genres defined your year? Which artist took your number one spot? And which club do you belong to based on your listening? Open your 2025 Wrapped for more stories and even more surprises. Happy Wrapped!
तो द लगन
महसूस करना चाहते हैं अगर हाँ
यार मैं
तो
लिखूं क्या?
हर टाइम पॉडकास्ट में आपका स्वागत है मैं सार्थक मिश्रा हर वेडनेसडे एंड सैटरडे डरावनी कहानियाँ आपके सामने लेकर आता हूँ सुनिए हॉरर टाइम पॉडकास्ट को मेरी आवाज़ में एक्सक्लूसिवली ऑन स्पॉटिफाई पर हॉरर टाइम पॉडकास्ट को फॉलो करने के बाद बेल आइकन दबाना ना भूलें
फाइंड द काउंट मॉडल यहाँ पे बेसिकली मैं 1 से 3 इस रीजन को रेड कर सकता हूँ पूरे 3 ऐसा बिल्कुल लगा सकता हूँ लाइक लगा लो मैं वहाँ पे एडजस्ट करूँ या तो मैं इग्नोर करूँगा ऐसा इग्नोर कर ही कर सकता हूँ पेंट करूँगा तो 2 एक साथ करूँगा है ना उसमें कोई पॉइंट ही नहीं है बीपी वाइज देखने का तो वगैरह मैं हो जाता है transition actually I will transition on either I want color only so I will go to I plus 1 to erase up their transition या तो मैं I और I plus 1 को कलर कर दूँगा I plus 2 skip डायरेक्ट I plus 3 लाऊंगा this can work as well और मुझे यहाँ पे लिखना है यहाँ पे I और I plus 1 पॉसिबल है एक्चुअली ओ एक्चुअली नहीं पता है जैसे यहाँ पे ये हो सकता है यहाँ पे मैंने आई प्लस हमको बंद कर दिया ना मैं ट्रांजिशन हियर सेइंग कि मैंने यहाँ पे ये कर रखा है प्रीवियस कलर इज M1 I know the number of colors available here यहाँ पर 1 क्यों नहीं डाल सकते मुझे बेसिकली पीसेस इन फंक्शन नहीं चाहिए पीछे क्या फंक्शन पीछे क्या कलर डाला था मैंने तो 1 डाला था क्योंकि वो M1 बी पी हो जाएगा एक्चुअली वो तो मैं O1 में आई थी पता लगा सकता हूँ कॉम्बिनेटरिक्स हैवी है। कॉम्बिनेटरिक्स क्या कहती है? यहाँ से आइदर I can iterate on count. Let I be the count of uncolored cells. इसलिए तो करना पड़ेगा जो एक सेल अनकलर्ड रहेगा तो दूसरी कहाँ से करना उसमें? फिर तो एक रीअरेंजमेंट हो गया, वो मल्टीनॉमियल हो जाएगा। Also rearrangements local. यहाँ पे अरे DPI बता देता है यहाँ से यहाँ तक का कितना वो है वेरिएशन है ना। बट इसमें DPI होगा कितना हुआ है? तो ये क्या है? तो कोई इन्फॉर्मेशन है साला।
It's that time of year again. Spotify Wrapped season is here. Wrapped is a celebration of the music and podcasts that made your 2025. And this year, it's answering all the important questions like what genres define your year? Which artist took your number one spot? And which club do you belong to based on your listening? Open your
अभी के लिए
2025
स्टे
Wrapped
करते हैं
for more
कलर और नॉट
stories
कलर
and
ये
even
भी
more
इतना हेल्प
surprises.
होगा।
Happy Wrapped!
कलर और नॉट कलर लिंक होगा है ना। यहाँ पे कलर नहीं है। हाँ तो कोई भी मान कुछ कलर नहीं डाला तो आंसर है सिर्फ यहाँ सारा आंसर है DPI बस 1 तो 0 और 1। लेकिन इसमें मान मैंने कोई कलर डाल दिया तो 1 आंसर इज यहाँ का आंसर। अज्यूमिंग यहाँ पे कलर नहीं है अगर तो यहाँ पे कलर और कलर ये वाला नहीं है कोई कलर है कलर इसलिए मुझे डिफरेंशिएट करने आना चाहिए कलर है नहीं कलर इज नॉट इक्वल टू दिस तो बेसिकली चेक करना है कि कहीं यहाँ से आंसर ले लो लेते हैं लेकिन आगे मैं सारे तक डाल सकता हूँ एक्सेप्ट अगर वहाँ पे ये कलर है बस अगर यहाँ पे कलर है तो मैं यहाँ पे डाल रहा हूँ तो पास इन द स्टेट कि एक आंसर एक मत काउंट करिए तो वो कर लेगा। मान लीजिए यूजिंग तो एक ही बूलियन स्टेट है। Okay, now what the problem is that I have to check quickly. Check quickly if जो यहाँ पे मैं कलर डाल रहा हूँ तो n का एक और लूप हो गया है। n का लूप I actually threw all the colors right. बस हमें मुझे काउंट पता चल रही है। काउंट में दो टाइप के होंगे, जिन पे आगे है कलर, जिन पे आगे नहीं है। And how will I know? कोई मैं प्री कंप्यूट कर देता हूँ। Basically two आई पे होना चाहिए, आई प्लस वन पे होना चाहिए, आई प्लस टू पे होना, थ्री पे तो ही डाल सकता हूँ, है ना। ये हो गया। अब देख एक ट्रांजिशन जाएगी, x into dp I plus 2 12 color canvas, है ना। But y into dp to 12 color cannot match or can match। And obviously blank if dp is I plus 1 and 12 cannot match। ये हो गया, मैं यहाँ पे आ गया हूँ। नो कलर है, cannot match तो आसान है। ऑप्शंस करेक्ट हैं तो प्रीवियस से मैच कर ही नहीं सकते, है ना? मल्टीप्लाई कर दूँगा।
It's that time of year again. Spotify Wrapped season is here. Wrapped is a celebration of the music and podcast that made your 2025. And this year, it's answering all the important questions like what genres
तो if
define
cannot
you?
cancel I can put
Which artist
anything.
took your number one spot? And which club do you belong to based on your listening? Open your 2025 Wrapped
Not
for more
cancel
stories and even more
can put
surprises.
anything.
Happy
So answer
Wrapped!
will be 0, comma, cannot 0. No color consequences. I, comma, x is equal to comma 0. DC. मैं यहाँ पे कितने कलर सेलेक्ट कर सकता हूँ, यहाँ पे कॉन्फ्लिक्ट कर सकता हूँ. Let it be x into DC. I R and DC I R DC x1 0. Okay, I have a transition. Maybe continuing from the same thing. I plus 2 और 0 हो गया. अब मुझे कॉन्फ्लिक्ट. मैं बेसिकली दो सेट्स में रखता हूँ. एक सेट में होगा जो आई, ये पॉसिबल है, एक्चुअली हो सकता है. डुप्लीकेट्स हो सकते होंगे, I don't know. लेट है ना, नो. चेक कर लूँगा. मुझे एक सेट में रखने इंटरवल्स जो आई से लेके आई प्लस 4 तक है.
आजकल ना नो बडी पुट्स इन एफर्ट
तो बेसिकली
एनीमोर.
मुझे
बर्थडे
इंटरवल्स
पे भी
यहाँ
बस
से लेके यहाँ
एचबीडी लिख
तक
के छोड़ देते हैं. पर वो अलग है. आई एम टॉकिंग
एक्स्ट्रा
अबाउट स्पॉटिफाई डे लिस्ट यार. मेरे लिए
है
दिन
ना.
में 6 बार प्लेलिस्ट बनाता है. फ्रॉम मिड डे ब्लूज टू मिडनाइट ग्राइंड. इट गिव्स मी म्यूजिक फॉर एवरी टाइम ऑफ द डे. व्हाट अ ग्रीन
एवरी
फ्लैग यार.
इंटरवल.
Have you tried Daylist? It's your day in a playlist. Search yours now.
Ah, it's that time of year again. Spotify Wrapped season is here. Wrapped is a celebration of the music and podcasts that made your 2025. And this year, it's answering all the important questions like what genres define your year? Which artist took your number one spot? And which club do you belong to based on your listening? Open your 2025 Wrapped for more stories and even more surprises. Happy Wrapped!
कॉन्फ्लिक्ट ये कब होगा जब चांस है जिसका मेरे पास. बेसिकली एल प्लस 2 से कॉन्फ्लिक्ट का चांस होगा. ओके. एल से आर माइनस वन होगा, है ना, ये तो फ्री वाला है। एल प्लस टू फिर आर माइनस वन कंस्ट्रक्टेड होगा।
is here. Wrapped is a celebration of the music and podcast that made your 2025. And this year, it's answering all the important questions like what genres define your year? Which artist took your number one spot? And which club do you belong to based on your listening? Open your 2025 Wrapped for more stories and even more surprises. Happy Wrapped!
ओवर काउंट हो रहा है। डीपी है। ओ मैं सही कर रहा था यार। अरे यार इतना क्या लिख दिया? डीपी नेट ट्री। Okay, so I'll try explaining the problems, the solutions for today's AtCoder bi-weekly contest 435. I'd say the problems were fairly easy compared to ABC standards, which is why I could solve 6. Like the list rating, say the max difficulty was 1368, which is for the F problem is less than usual. G was fairly hard. I still have to give it another shot. So the first two problems were straightforward here. Like you could run a loop for this, or you could just use the Gaussian sum formula, which is this n into n plus 1 by 2, so O of one solution, or the constraints were low, so you could run a loop here as well. B was also the constraints were low, so basically just for every pair we can just iterate on every pair which would be n square, and for each pair run another loop to get the sum and check if every value is divisible by it or not, and then return true or false. And by return I mean add to the result and then print the result. So the first two problems were fairly straightforward. C was interesting. Basically these n dominoes were standing in a line. The ith domino was at the ith coordinate and the height of the ith domino was ai, and we had to basically tell, like, if we push the first domino, like what is the how many dominoes in total will fall. So basically, like, this might seem, what do we say, imposing at first, but a fair bit of visualization would help here. Just draw a line. Basically, since we are manually pushing the first one down, it will, like, if some domino is at I and if it falls down, it will reach till I plus ai minus 1, right, as the problem states here. If the ith domino falls, so basically, my bad. So basically we can just run a loop here for after the first domino falls, we know, like, what's the rightmost point which is falling. So we can check if the next point is less than equal to the rightmost point, then that means that domino will fall as well. So now we can maximize either this domino, either the new rightmost point is inside this or it's outside this. If it's outside this, that means it can cause more dominoes to fall, right? So we can just maximize this using this. Mx is the rightmost point, so 0 plus, since I am using 0 based indexing here, so it would be 0 plus a0. And if mx is less than I, which means the current domino won't fall, so else we break and print the answer, else we maximize the rightmost point and increment s plus plus. So this was Q3. Q4 is basically we were given a directed graph with n vertices, m edges, and mr3 e5, and it's a directed digraph with edges from xi to yi. Initially all nodes are white, and then we had to process two queries in order, and the queries were of two types. The first type was we color the vertex black, and the other was we need to tell if it's possible to reach a black vertex by following edges from the u vertex. So basically, one second, like, given a digraph, it's going to be blank, but alright. Let us see the diagram for now. I guess, yeah, much better. So basically it's directed, so we can only go across one direction in the edges. Now if we, let's say, if we color this edge, we need to tell if it's possible to reach. So basically we need to think about our query first. No, 1 second. We need to think about our query first, right? If we let's say this node be the query gives us this vertex, we need to tell if it's possible to reach any black vertex from this vertex. And if let's say this vertex is black. So for every query, it would basically, if we do it naively, we would maintain an array which will store the color of every vertex, and in the other type 2 query, and we could flip this based on the query of course, and in the type 2 query we would just run a DFS or BFS or whatever, which would be n into q plus n actually into q, which will TLE since this is 3535. So what we do here is, instead, like, assume we flip this color to black. Now what happens is, all of the vertices which can reach this, we can also temporarily turn them as black, right? Because like this vertex can reach this. So instead of doing this, what if we make a reverse graph, like if we reverse the edges of the graph, and as soon as we turn some edge vertex black, we initiate a BFS or DFS whatever from this on the reverse graph and see what all we can reach there. Because if after reversing, if this is black, if we can reach some set of nodes, that means in the unreversed graph, if we started a DFS from any of those set of nodes, we will be able to reach this, right? And this is guaranteed to work because from our implementation here, this is just taking the input and building the reverse graph. This is reverse. This is from V to U, even though the input was in U to V. So what we do here is, we maintain a visited array where visited means black. And now if the type is 1, it's a type 1 query, and if it's not visited already, then we visit it and then we initiate a BFS from this node. And we only visit the neighbor nodes if they aren't visited already. So since we are visiting every node at most once, in across all queries, the time complexity is n plus m, and O of 1 is for answering if the node has been visited. That means, let's say if this node has been visited, this means we have done a BFS from on the reverse graph via a node which is colored black. So that means on the unreversed graph we will be able to reach any black node from this node, which is basically what our query demands of us. If this was not directed, if this were undirected, we could easily use a DSU to solve this. But I guess that was in the first variant of the problem. Cover query is fairly intriguing as well. This problem is also a fairly common pattern. 1 second. I guess. Yeah, this problem. It's similar to this problem, where you need to track some intervals. So here basically, assume we are given a number line, right? Instead of cells, assume it to be a number line. 1 second. Assume it to be a number line. We have a number line from, it says 1 and n plus 1, which can be termed as infinity for us because it doesn't exist. Now initially all these are, what are they? They are white. We can basically select a range and make it black. If it's already black, then it stays black. And we need to tell the number of cells which are white. Obviously, if we can tell the number of cells which are black, then we can just do n minus black to get white, right? And assume we make an interval like this black. So this is an interval, and then we make some other interval black. And now since if we make some other interval black, what it does is it will merge these intervals. So all these we select this. Now all these intervals are replaced by this single interval. So basically then this becomes a problem of interval merging and addition, which is just, now it's an implementation problem. Like, it will depend on how you interval. A common way to implement this intervals is how I learned is, you can use in C++, you can use a regular set of a pair. The pair will store this L comma R, right? It will be sorted based on the left index, the left interval. These are closed, by the way, it's inclusive intervals. Now assume we are given 1 comma 3 is one interval, and the next one is, let's say 6 comma 7. So now assume we are making 2 comma 6 black, right? So what happens here is, if we look at this, the physical representation, assume this to be numbered like regularly. So we have 1 comma 3 and we have 6 comma 7. Now we are adding 2 comma 6, right? So the interval will start from here and then it will end at this place, not this. So basically we can from this arbitrary operation we can see that we have to go to at most like one interval to the left, since it can technically, like in simpler words, eat this, and then it can stretch to the right and eat some other intervals. So we have to implement this. For implementing this, basically we need to find the interval which is just to this its left. So for just to its left we can do this previous of upper bound li comma 0 because we will never have 0. And to find the first interval which we don't care about, it will be the interval which is just greater than r, so just greater than 6. So it will be something of the form 7 comma infinity. If we put 7 comma 0, we can get it misplaced by some 7 comma not 1, let's say 9, which we don't want. We want it to be greater, but I meant 6 comma 9. So here we would do upper bound on 6 comma infinity, and infinity for us is n plus 1. We can add these flags, it just makes implementation easier. So we just merge it, we keep track of the number of black cells. If any interval gets erased, we remove its size and we just adjust the current intervals, basically the left and right here. Or for like if you are erasing elements in a set, I'd recommend not erasing while you're iterating. There is a way to do it, but I'd recommend just store them in a vector, the points which are to be erased, and then erase them later. So here all the points which are erased, I am removing their contribution and I'm adjusting the left, and now here the since this was extending leftwards, only the left coordinate is adjusted. But after this, since I'm extending rightwards, I'm eating some intervals, right? So based on this, I'm adjusting my right coordinate, right interval, and the count variable is adjusted accordingly. Here I'm erasing all the intervals which were marked to be erased from my intervals, and I have the final L comma R interval after eating the ones to my left, if any, and to my right. So I just insert it and I increment it to my count, and at the end we print n minus count, because count currently is the number of black colored cells and we wanted white, right? Yeah, we wanted white, so n minus black. Here you could try this problem as well. This is similar, like you have to design a data structure. Here the interval is half open. So here we can add range, and we need to query if every element in the range is correct. So it's kind of similar to this. Implementation, I took longer on implementation than I should have, but alright. And F was a fairly, like, it was an interesting problem. It wasn't straightforward, but it was like once you understood the thing, it was easy. So the idea here is we are given a permutation of size n, where n is less than or equal to 2e5, yeah. Given some permutation. Now we start from the highest number, and after we can either go, if there is a number, we can only move in adjacent cells to adjacent indices. Actually, assume a better example. This is 5. We start from the highest number, and then what we can do at every number is either go left or go right, and we can only go if it exists. Like, but we would go to the place where the number is of the permutation. Since it's a permutation, all numbers will be unique. We would go to the index where the number is the highest, and it's connected to this. Basically, like, assume it's a connected component here. Now this gets cut, right? So from 6, now we cannot go here since this place is this doesn't exist anymore. And here we travel one distance. Now from 6 we go to the next highest. Since we can't go to this side, we'll go here, 5. And now the distance gets that gets added is 1, 2, 3, 3, right? So the total distance. So we just simulate this. Now this gets removed. So from 5 we go to 4 and so on. Like once you understood this, you can basically just reframe this problem like this cat at every index is just making a decision, right, of going either left or right. So for modeling this decision, an interesting thing to note here is we aren't visiting any index more than once. Like assume this is us, this is our cat, we go here or we go here. Now when we go here, this becomes our range, right? Since when we are in this range, we cannot go here since this gets removed, and we cannot traverse across this removed cells. So this will never get visited again, either from the left or from the right. So from this observation, you can just write a recursive brute force where at every index we go, if there exists a left and right, we go there and we just take the maximum of their answer.
I'm
Now
a
for
one
getting the
zone kind of
answer,
person. The comfort zone. मेरी ना एक simple
as we
philosophy
know,
है.
the
Why change
cat will
something
go
that
to the,
always makes you
like
happy?
it will, like
And
if we are going to
Spotify's
the
on
right,
repeat playlist just gets that. No drama, no surprises. बस मैं और
if you are
मेरे
going to the
trusted
right, it will go
bangers.
to the number
So
with
for
the
someone
highest
who
value,
wears a
right?
t-shirt
So
till he
in this range,
qualifies
we
as a
want
porch lover,
the
this
highest
feels like
value.
my
We just want
happy
its
place.
index.
For all
If
your
we
current favorites
use
in your
a
playlist, just
star
search
max
on
element,
repeat on
not star.
Spotify.
If you use
Takes
a
about a
max
minute.
underscore element, this will be O of n. It will be linear,
It's that
which
time
will
of year
TLE
again.
since we are visiting
Spotify
Atmos. Like
Wrapped season is here.
if our cat jumps
Wrapped
like
is a
this,
celebration of the music
this will
and
be n square,
podcasts
right?
that made your 2025. And this year,
So we
it's
can use
answering
a
all the
linear
important
range
questions
query
like
sparse table
what genres
to get
define you,
the
which
min
artists
max
took your
value and
number
its
one
index
spot,
in O of
and which
1
club do
after
you
a O
belong
of
to
log n
based on your listening.
pre-computation. Like
Open your
if you
2025
don't know about
Wrapped for
sparse
more
tables, there
stories
are
and even
there
more
are fairly helpful
surprises.
data structure for
Happy
linear
Wrapped!
range queries on idempotent functions like min max, GCD and all. And here we, since we care about the index more, we can use a trick where we, instead of building the sparse table upon the values, we build it upon like pi, right? Pi. So we build it upon a pair of pi comma I. And here, since pi is unique, all their corresponding I will be unique as well. So when we maximize this, since it's a pair, it gets maximized lexicographically. And since this is always unique, we will get this the correct index as well. So we can just destructure it as this irrelevant thing and the index. And then we can jump from here to here, and that will be the cost. And then we can call this upon this subproblem. It's sort of like divide and conquer. So this was my sparse table template. I don't need to change anything here, just make it max if it wasn't already. And I made it on pi comma I, built it in login. I could have done use sparse table only, but whatever. We start, this is our initial range, right? 0, 2 and minus 1, and this is the starting index, the max index. So from here, if L is greater than equal to R, only one element remains or empty, we can't do anything, so we return 0. Else, if the right region is unempty, we get the destination index. This underscore is the value which we don't want, is irrelevant for us. This is the destination index, so this is our cost since we are moving to the right, and we call it here update answer, same thing, and then return the max. This was fairly straightforward using this. So yeah, G, I was trying some DP thing. I think my idea was correct, but I couldn't implement it properly. I'll have to read. The problem was rated for like 2300, so like it was, there was a low chance I would have got it anyways. Alright, so this was the Jank editorial. I guess there wasn't anything to explain here since the problems were straightforward, but I got positive delta, so I guess I'm happy. Alright, I'll make another editorial if I find the time or if I perform well. Bye.